We've had build issues where I look at the back of the panel, I'm like, far out. What turkey was on this line with the silicon work?
Up until now, you would be spending double the price to get that look.
These 25-year warranties, it's not saying, we're going to put a whole new solar system on your house. It's a far cry from that. Last week, I sat down with Brett Robinson from LONGi Solar to record this interview about their brand new HiMO-6 panel. It really is a beautiful panel. But towards the end of the interview, I brought up a problem that I've got with the panel, and on reflection, it's a deal breaker for me. So that's why I called this interview Why I Don't Sell LONGi Yet. But I'm hoping that's going to change. If it does, I'll link an update above. I hope you enjoy this interview. Okay, today I've brought in Brett Robinson from LONGi Solar, and we're going to talk all about this brand new HiMO-6 panel that is out. I'm loving this panel. It's quite unique, quite different, a big step up. So we're going to talk about kind of the spec sheet things, and I guess the things that you would want to talk about, Brett.
Sure.
Talk also about price, just sort of where this sits in the market a little bit. And then I want to get into the things that I look for in a panel. We might even have a little bit of a debate and a disagreement maybe, which is all fine. So, Brett, thanks for coming in today. Tell us about this new panel. I guess the first thing that stands out about it is I can't see any lines across the front of it.
That's right. So this is our brand new HiMO-6. It's LONGi's own technology. It's a hybrid passivated back contact cell. So back contact, which means that the front of the cell is clean from all electrical bus bars and connections. And so what that does is that allows sunlight to enter the cell on the front without any shading or any obstruction. And of course, more cell production simply means more efficiency. So the product itself is up to 22.5% efficient as a module. So it really does kick the goals in terms of being able to deliver more power into the same size as current 415 watt panels. Yeah,
and it's got a lot more going for it than that, but I think if we were to sum it up, what the customer is going to look at is it's a back contact, no bus bars on the front, and the performance of it. Let's talk a little bit about efficiency of the panel. Efficiency, people kind of think, an efficient car doesn't use much petrol or whatever it is. What does efficiency mean on a panel?
So the reality is that the panel size is really important for installers. It can't be too big, so you can't just have the biggest and the most powerful panel going onto a roof because, quite frankly, that's too dangerous.
If you're in a solar farm, ground mount, maybe, that's fine, but not in residential. Yes.
No. So the good part about our panel is that it's 1722 millimetres high and 1134 millimetres wide. It weighs 20.8 kilos, which is certainly more over a kilo less than the current mainstream N-type TopCon products.
Yes, okay. And so dimensions are exactly the same, as it turns out, as the Q-Cell and Canadian panel that I'm installing at the moment. But I'm installing a 415 watt panel. Tell us about this one.
Well, the difference is efficiency. So because we have no architecture on the front of the cell, we have it on the back, so that allows more sunlight to penetrate through.
And so we're getting 440 watts, which is a big step up. Normally you get sort of 5 watt increments. Okay, let's take it a step back a bit, Brett, and talk about who LONGi is really briefly. Don't give us a half an hour, waffle about it. But who the heck is LONGi anyway?
We're the largest solar manufacturer in the world. We made 90 gigawatts of wafer last year. We made 48 gigawatts of panels. So just to put that in context, on the current 440 watt panel, that's about 110 million panels. It's mind blowing what we sold last year.
Yeah,
but you've got to understand that 80% of the world's demand's in China, the US, and Europe.
Yeah, largest, not panel manufacturer, because we're talking Trina and Jinko there, right?
We delivered more product than they did last year.
And you're talking when you're saying that wafers.
And then there's wafers on top of that. So,
you sold more panels than they did last year, effectively.
Absolutely, yes.
Right, okay, I didn't realise that. Okay.
The bottom line is that our large customers understand not the brand power, but the R&D power. So in other words, there's gravitas, there's weight behind the brands that they buy. And there's no secret that Jinko, Trina, and LONGi are the top 3 manufacturers in the world.
Sure.
And they manufacture more than 50% of the world's use. And the reason is that we collectively, we make the best products.
LONGi started out in about 2000, right? Making wafers?
We first started in 2000. The three engineers that started our business simply loved pulling a single crystal out of a bath. So since then, we've been making monocrystalline. So our first product was going into the computer industry as silicon chips, and then they decided to go into the solar business.
Right.
So the whole time we've been making monocrystalline product, so P-type cell mostly, which we still make today. So our HiMO-6 is actually a P-type wafer with various coatings and detail done to it to create our new HPBC product.
Wafer is basically the raw silicon that's been cut. They turn this into a big block and they slice it up, and that turns into a wafer. You guys make 30% of the world's wafers? Is that something like that?
Something like that.
Yeah, which is crazy. So, and that's where we started off. Now, when we turn it into a cell, you're etching and what's the word for turning it into a cell?
Well, in some of those instances, in fact, for this one here, we use a hydrogen passivation process to that, and we actually use hydrogen to affect the top of the cell. It enables a more even spread of energy to be going through the cell. So that's part of our top secret process with this.
Yeah, okay. And so that's a lot of the technology, right? And that's where panel manufacturers differ, right? Is the technology that they use to make the cell, turn it from a cell into a wafer, which is a massive part of it. You guys have effectively then, instead of putting bus bars, where we transfer the electrons from one to another and from the panel to itself, you're basically putting those bus bars or tracks on the back of the cell, so you're not blocking the sunlight.
Exactly, and so what you get is this aesthetic look. So it's a high profile, clean aesthetic look that up until now you would be spending double the price to get that look using other people's products.
Now, I want to point out something really obvious here is that everyone's going to look at that panel and say, I don't know if it's in shot, but my SunPower panel over here, it's basically a rip-off of that, but except you cut the cell in half. I want to point something out first, is that this is SunPower. I love this cell. I think it's a great product. And if we go to break it, it sort of breaks, but it stays together. For the record, I don't love SunPower. You still have to assemble a panel, and they haven't done a very good job of that, in my opinion, my experience. But so that is a SunPower cell. They've got copper on the back, so it holds together. LONGi differs from that in the sense that this is their cell, and this is what the rest of the market uses, right? And in reality, they're fragile. They're not. They don't hold together well. Tell us the difference in reference to that about P-type and N-type.
If you want it to work well in situ, out in the field, as opposed to making, world records in a laboratory, the product's got to be robust. So the micron thickness of our P-type wafer is about 150 microns, whereas the current N-type product is anywhere between 130 microns down to 110 microns. Now, of course, the thing is that the thicker that the product is, the more robust it is in real life. So when you go down to thinner product, you're really starting to take some risks.
Yeah, and you do see that, like guys carrying the panels on the roof, if they're flexing or in transit or whatever it is, if you're not careful with how you're handling that module, or some turkey gets on your roof and walks on your panel, which is probably going to happen sometime in the next 25 years, you get this crack in the cell. Obviously it stays together, so you don't even see that crack, but then you're really affecting the production of that.
Absolutely.
That panel.
So when cells expand and contract, because they're out in the sun, they get hot themselves. That's an issue where you have to have a robustness. You have to have a certain thickness to get there. Yep. So with our back contact product, the other weak point is, of course, where the cells themselves join. So in a normal cell, it's like a Z section. So they connect the top of the cell to the back of the cell. It's just the architecture going through.
Just show you a different shot about that. So the difference between the standard panel at the moment, the standard split cell, where the wire goes on top and then underneath, and then on top, and then underneath, and then that's sandwiched on glass and your back sheet. You guys are just running the wire along the back, or the contacts along the back.
Absolutely. And so what that does is that reduces the stress on the solder in between the cells.
Yeah.
So when people talk about hot spot or micro cracks, invariably what they're talking about is also the micro cracks in the solder. So you get micro cracks in your solder, and your product isn't going to be moving all of that electricity through it.
Yeah.
So with our back contact product, it's straight lines. It reduces the stress on those parts of the cell and the parts of the solder by 50%.
Yep.
So there's less pressure, and so there's less opportunity for micro cracking to happen.
Yep, and in a lot of ways, that's how SunPower did it too. It's just, they weren't weaving in and out, but this is different from the panels that we're seeing, the split cell panels that we're seeing today. Now, one grief I have is new panel technology, right? So when the shingle panels came out, I was kind of like, oh, far out. This, they start pasting it and it's all completely different. And I really wasn't impressed at all. Went to a factory, saw it produced. I was not impressed at all about seeing the production. And I think time proved me right from what I'm hearing. We installed for a couple of jobs like that, and then stopped it when I started, making sense of it. And talking around the industry, shingle panels was a terrible idea, or there's been a lot of failures. Maybe they've improved that now. What I'm concerned about is new panel technology.
Well, that's true. I suppose I'll come back to an earlier point that I made, and at the end of the day, it's actually got to work in field. It's got to work on your roof or in the field or in at the top of a mountain or right next to the ocean. It has to work in those sections. So that's what we have with the HPVC product. It's using all the product that we've been using now for many years for our P wafer and all of the basic raw materials that are going on to the product. So we're using existing technology, existing materials, and we know that they work well in situ. It's just that we've got them with a lot of money being spent on R&D in a different configuration to improve the efficiency of the P-type.
Now, one thing that also impresses me about this panel is the temperature coefficient, which I remember when REC came out with their Alpha Pure R, a panel that we install, absolutely top of the line panel. Temperature coefficient was down, I can't even remember what it is, but 0.27 or something like that. What is your panel temperature coefficient of it?
We make claims that it's 0.29% per degree.
Which is insane, because that's come from, maybe we need to step it back. Why does temperature coefficient matter? I think a lot of people that dig into panel specs think that this is a problem, but yeah.
Well, in many markets in Australia, we're generally talking about hot markets. So the hotter the product, the hotter the environment, the more sunlight that gets to it, the hotter the cell gets. And as a cell gets hotter, it becomes less efficient, and it reduces efficiency, in our case, with this one here, by 0.29% per degree above the standard international testing standard.
Yeah.
So it just simply means that in hot conditions, like we experience in many parts of Australia, this product puts out 6% more than what we were doing before.
Yeah, so I think people don't understand that, especially customers. They think, oh, it's a stinking hot day today, my solar's going to be cranking. Actually, higher temperature reduces the production of a panel.
It does.
But not so bad when you've got the lower that temperature coefficient is basically saying, well, this is not going to react to temperature as bad as before. I've always thought that temperature coefficient, in my mind, isn't that big of a deal. So let's say I install a 10 kilowatt inverter. I'm probably going to install around about 13 kilowatts of panels on it. So when in the middle of the day, the temperature is at its hottest, we've overpowered that inverter anyway, right? So I don't know that temperature coefficient is a huge thing when it comes to production when you're oversizing your inverter, right? It may make a little bit of a difference here and there. What I thought was more interesting, and I hadn't heard this explanation about temperature coefficient, is if the reason it's happening is you're running your panel cooler.
Well, certainly the 182 millimeter cell, which we use for the HiMO-6, runs cooler than our previous size, which was in our 370 watt panel, or the 210 millimeter cell that other manufacturers use for their product. So it runs a bit more efficiently, and it takes energy out of the cell a bit more efficiently, which means that the cell runs cooler.
Yeah. And which, as I understand, is just going to be better for the cell. You're not going to, anything that runs cooler is going to last longer, potentially not degrade?
Well, ask an inverter manufacturer about being
exactly.
height, and they'll tell you all about heat. So.
Yeah, well, that's one of my big bandwagons. Why I love Fronius is because of the fans in it, but I've never really thought about it translating to a panel, but it makes sense. Yeah, so this is what I find interesting about the panel, is because we're talking about all those 1%ers that add up, right? Which is nice to have a premium panel. This is not a premium panel price. We're talking, in my understanding, and for what I've seen about price, and we're not going to throw out a price of a panel here, but we're talking around about the same price as your standard Chinese panel, as Jinko, Trina. We're still in that sort of price range, aren't we? We're not talking about sort of double the price to go up to SunPower or REC or, you know.
Oh, absolutely correct. LONGi is a full-scale manufacturer. We don't do niche production, right? So we spend our R&D money to bring better efficiency into mainstream sales. So this may be a charming, aesthetically pleasing product, but as far as my business is concerned, it's another new mainstream. So we see this as the new mainstream.
Okay, so let's get on to what I look for in a panel. When I'm down in the warehouse there and we're getting panels in, we get a new container, especially when we get a new container of new panel in, I'll be down there opening the boxes, going through a few pallets of panels, looking especially at the silicon work, the frame quality, the sharp edges, how square it is, all these kind of things. You'll be surprised to know, Brett, that we normally install the top end panels, right? SunPower, Q cells, REC, and we do Canadian at the moment as well. But with all of these panels, the top three anyway, we've had build issues where I look at the back of the panel, and not always, but I'll crack open a container and I'm like, far out, what turkey was on this line with the silicon work? I was happy to see this panel here was probably up there with the best I've seen. The silicon work is absolutely perfect, obviously done automated. So really nice build quality. I'm hoping it stays that way. That's what I look for in a panel. Now, there's other things, and this is a little bit of a bandwagon that I get on, is the warranty of the panel. Now, I've been talking about this for years, and it's happens with most panels, but I've had some win with some panels, is that in the installation manual, it says you can never install this panel in the shade. What happens if, what happens, let's start off, if I install a panel behind a chimney or something like that?
I'd see you on Crap Solar website. Yeah. That's what I'd see.
Okay, but if I come back to you later and I say, that panel has failed, I want a warranty on it.
The people that install 95% of solar in Australia are qualified, accredited, and conscientious individuals. Right? So now you're describing the 5% that don't do the right thing. Right. And at the end of the day, we're not there to cover someone that's done the wrong thing or done it in the wrong situation. So if you're getting shade at midday, I'm not sure you should have had solar in the first place.
Yeah. Oh, yeah. And I'll be honest, it happens all the time. In fact, we've done it, and then a customer has put a flyover over the roof, and it's hard shaded the bottom of those panels. They all failed. I didn't expect to get a warranty for that. It wasn't our install. It was after us that they shaded it. You can install behind a whirlybird and you'll get a hot spot or something like that. I think those warranties should be void because shade can kill a panel. The problem I have with every panel manufacturer is they say never shade a panel. Keep the panel out of the shade. And I always ask, where is the line in the sand for that? My understanding is somewhere between 10 and 2, never shade a panel. Something like that. I don't design panels. I don't engineer them. And I kind of get your point that generally speaking, at the moment, panel manufacturers are honouring warranties regardless. If you do between 10 and 2, I would think they would void the warranty. If you've got shade at 9 o'clock in the morning, they're saying, well, that didn't ruin the panel. The problem I have is that's not what the install manual says.
Well, and in general terms, if you're getting shade between 10 and 2, you're just not getting shade on one panel. You'd be getting shade on multiple panels. You're looking at a system that's just not performing very well.
Right. Yeah.
And at that point, like whether it's that you claim it as a warranty issue on my product or not, you've actually got a major system problem. And that comes back to the installation.
Well, we've got a roof problem there, but they still wanted solar. So sometimes you can't avoid shade if you want to get solar on the roof at some points, So, maybe that chimney is only shading in winter time. And I think what the industry needs to know from manufacturers like yourself is we need to know, okay, where is that line? Give us some kind of guidance, because I can guarantee you in 15 years' time, we'll go back claiming warranties. And I don't know what it'll be. I don't think they're going to knock back a warranty for shade at 7 o'clock in the morning. But I think shade, talk to any engineer and solar engineer, and they'll tell you shade is a major issue. And I've had engineers from Qcells going, no, what do you mean? You can't ever shade a panel. That ruins a panel, right? And I think they're probably right. I think this is what I need. By the way, I'm going to shoot some videos about Qcells and Canadian Solar and REC. I've pushed hard on especially Qcells and Canadian, and I've got some changes in there. I think it's something that we need to see changed in the industry with shade. But I'll get off my hobby horse on that one, and I'm going to get onto my new hobby horse, which is about the problem that we're going to have with panel sizes in the future. So the other day we had a fault with a Trina panel that we installed years ago. Nothing to do with Trina, right? You get faulty panels. And we were trying to find another 250 watt panel. This is obviously from several years ago. It had failed. Trina doesn't have any 250 watt panels anymore. So we're down to my warehouse trying to find, we've gone through a lot. We try to keep stock of 250 watt panels, or every panel that we do, we've run out of them. So we're scrambling around trying to get another 250 watt panel, because what they offered was a 330 watt panel. And I'm thinking, well, that's going to probably work electrically fine, but it's just not going to fit in this.
Size.
We're going to have to put new rail on the roof. It's going to look ugly. It's going to look different. Especially, let's say it's in the middle of the array. This creates a whole lot more work when we're shifting all the panels around. Now, what LONGi says, and again, I'm probably not just picking on LONGi, but an industry issue, but LONGi says it very clearly, and from my recollection of this, and you can disagree with me on this point, but from my, not recollection, understanding, and we might put this up on the screen, the way the warranty is read is that, let's say in 12 and a half years' time, halfway through the warranty, now let's say at that time a panel is worth $200 or something like that, okay? Well, we've gone halfway through the warranty. Let's say that panel fails, then the warranty document says you can give me $100, half of that price, and that's what the customer should expect. These 25-year warranties, it's not saying, we're going to put a whole new solar system on your house if it fails, right? It's a far cry from that. So
it is. And so part of that's our performance warranty, which of course goes for 25 years. So if the product is not performing at the level it should, then according to our warranty document, we'll give you the calculation based on that. So what's happening at the moment is exactly what you're describing. So people are coming to us saying, I need some kids have thrown rocks on my roofs, and I've got a smashed glass pane on one of my panels, and I need a 330 watt, which I'm currently giving some to someone up in Townsville. But the issue is that how is it that architecture? So it's just the size of the panel. You can't just click a new one in.
The width of the panel, the dimensions of the panel,
the thickness, everything is just different, and we can't stop like the improvement over years. It's going to turn into the case where recycling in the future will actually provide some of these outcomes. So at the moment, I'm on a committee with the Smart Energy Council. We're working with the Queensland Government on a second phase trial where there's going to be recycling of solar panels coming off roofs. So they'll come off the roof, they'll be assessed to say whether it's producing energy or it's not. If it's not, it's sent for recycling. If it has producing and it is producing energy and it's safe, then it's going to be put aside for sale or reuse somewhere else. And I suppose that's where we're going to get to. So
I think that's a reality, and I've been trying to get a clear answer from manufacturers like yourself about this, but I think you gave the best most realistic answer. That's what's going to happen. And we take 250 watt panels off the roof all the time, and we store them down in the warehouse if they're still perfectly fine, made by a good manufacturer. We test them. And then, whether the panel fails or what, at least we can look after our customer, Big problem I should point out too is that this is why you're first looking for a good panel in the first place, because this warranty isn't all it's cracked up to be. And you're looking for a good installer that's going to be around, and because no one no one looks after solar orphans, you know. If you've had your system installed and the company's gone bust, that's not my first priority, is to go and fix that system. I've got my customers to look after, you know.
Absolutely, it's a risk profile, and some people have more of a risk profile than others. And at the end of the day, it's exactly the same decision that you make for many of the things in your home. Our recommendation always is, buy once and buy best.
And in reality, let's say somehow you can prove that panel is performing at 70% when it should be performing at 90%. Well, effectively, LONGi is saying you can get the cost of 20% of that panel, or half of the 20% of that panel. So it could be $20 in reality. So, you know, these warranties, I think we should I just want customers to know in reality, they're not all that they're cracked out to be. What's probably much more important is first, choosing an installer that'll look after you with, like you're saying, what do you call it, junkyard panels or something like that, you know?
Maybe not that one.
What did you call it?
It's exactly the same as your car. So your car gets to a certain age, you stop going to the dealer to buy spare parts, you start going to the wrecker to buy spare parts.
Wrecker, that's what I meant, not the junkyard.
You're not the junkyard.
So this is going to be a reality. So first, you know, have an install, choose the right panel. Make sure you're not just choosing the panel just on price, but think about the design of that panel, and choose an installer that's going to be looking after you to go to that wrecker yard to get another panel. Or
correct.
Okay, Brett, thanks for coming along today. A really good chat about your brand new panel, really interesting panel, and it'll be interesting to see how this goes in the future when it's on the roof.
Absolutely, and thank you very much for your time today, Mark. I really appreciate it.
Thanks, Brett.